guys, this is SyedaZaidi, and today I'm going to be talking about 7.1 in pre-calculus, and this is lesson 1, and we're going to be talking about system of equations. Now, system of equations is basically a set of two or more equations using the same variables. So most of the time you will see equations like together and you will have to either add them. The thing is, sometimes they're not actually fully simplified, so you're going to have to like multiply one of the equations to make it both look like identical. And when they do look identical, you're going to have to start like adding. So sometimes there are actually subtraction, multiplication, and division too. But most of the time we're going to be using addition. But yes, so linear system is a set of two or more equations with the same variable. That's also another one that you should know also. And then solution consists of values for the variables that are solutions of each equation in the system. So now this is solutions, like whatever you get, it's a solution, and like you just have to try finding the solution and all that. So basically, this is like the vocabulary that you should know about, and I'm gonna start giving you another review of what the other part you should know. Okay, so this is the second part of the review, and this one is basically shows you like what kind of case definition they have for solutions and the name of the system. So the first one we're going to talk about is the linear intersect. So they have only one solution, and they only have one solution, and they are independent, inconsistent. Or is it codependent? Consistent, independent. Yeah. So next case is the parallel lines. Now the parallel lines are not equal to anything. They're zero. They have no solutions at all. And so basically, if you find a system of equations that are no solution at all, just put no solution. Don't put 0, 0. Well, it's 0, 0, but most of the time people use no solution as the answer for parallel lines. And then they are inconsistent. Okay, since they're parallel lines, they're like in the graph, they're like this, right? And then the conceding lines have infinite many solutions. So basically, it's like example 0 equals to 8. If the answer is 0 equals to 8 with the system of equations, that's basically a true answer, but it's basically infinitely many solutions. That's what it means by true. And then there are consistent dependent. So this is basically what you should know for these kind of cases, because these kind of cases are actually the systems we're going to be talking about, or we're going to be solving, and you will see like how you will see the difference between how it's 0, and then they have one solution here, and then one is like and then one is true. So basically infinite many solutions. Yeah, so let's start with the equations. Okay, so this is the first problem, and in this problem we're going to be using elimination. Now most of the time we're going to be using elimination but either way, even without the elimination, it's still the same thing, it's still the same steps without multiplying anything, or without eliminating anything else. So let's see how this equation is. So there's two equations. This is how the system equation looks like in an equation in the problem. And it says that solve the system by elimination. So negative 5x minus 2y equals 6, 3x plus 6y equals 6. Now this is going to happen because we're going to be eliminating stuff. So let's see how we can make it similar. So we can say that, listen, the y part always have to be the same, except one has to be plus and one has to be negative in order to make it the same, because we're not gonna be solving for y first. We're gonna be solving for x. So if you want to solve for, you could solve for for y if you make them same, but since you can see they don't really make any sense, because like they're both like odd numbers, they don't have anything that would be together. So we're gonna be doing y, and you see how 2 times 3 equals 6, and 6 divided by 3 equals 2. So we're gonna be doing that, and we're gonna be solving for y, and then we're gonna be solving by x by substituting substituting the x in one of the equations. So let's start with eliminating the equations first. So we can say that So since this is 6y and it's already negative right here, we're just going to use 3. Okay? Now, when I'm multiplying by 3, I'm not multiplying both of them by 3. I'm only multiplying the first equation by 3, not this one, because this one's already simplified. We're just going to use this one to simplify by 3, so the y is the same, so the y sum is the same. Okay? So when I do multiply that, it will be negative 15x minus 6y. Now you see how 3 times negative 2 is 6y, and then equal to 18. So 6 times 3 is equal to 18. So it's kind of like distributing with the 3, okay? Then obviously it just be the same, okay? It's going to be the same now, okay? And now you're just going to be adding. So when you add them together, it'll be a different equation. So it will actually cross out a lot. So negative 6y plus 6y is actually what? 0, right? So we're not solving for y, we're solving for x first, okay? Now, negative 15 plus 3x equals to negative 12x equals to 18 plus 6, which equals to 24. Then negative 12, and x equals to what? Negative 2. Okay, now we found negative 2, right? That's the x. We found x, okay? Let's just square this so you guys know where I'm talking about. This is x. We solved for x already. Now we're not done yet, because now we have to solve for y. So y, let's replace any of the equations. So let's just replace the first one, for example. Negative 5x. Okay, actually, let me just replace it right now. So negative 5, and then we're going to use negative 2 as x. And I messed up again. Minus 2y equals to 6. Now the thing is that you're not going to use a simplified part 2 in order to substitute. You're just going to use the one that was originally in the problem. Okay, don't use the one that's simplified. Don't use that. Only substitute when you're using the ones in the problem originally. So negative 5 times by negative 2 minus 2y equals 6. Okay. Now when you multiply all of them together, it'd be a total of 10 minus 2y equals 6. Then you're going to subtract 10 on both sides. And then you'll be left with minus 2y equals to negative 4 divided by negative 2. And now y equals to what? 2. So now you see how we found x and y? Now together it would be basically negative 2 and 2 as the point. Sometimes there'll be graphs showing like which line goes which, but for now we're not gonna be doing that. We're just gonna be talking about the system, how to do elimination, what kind of. This is a one solution, okay? This is a one solution. Just so you guys know, because I'm gonna be showing you different kinds of solutions, and then you're gonna see how they are compared to each other, okay? So the answer is so basically the answer is negative 2 and 2 and the one solution. Okay, so this is number 2, and this is the same one. So they solve this system by method of elimination. And so how are we going to do this? Now, previously we talked about elimination, how elimination works, right? This is the same way. So I guess there's the same y too since last time. I just realized that. So basically what we're going to do is that we're going to be multiplying this, the bottom equation, by negative 2. Because as I talked about this previously, I talked about how they can't be the same positive number. They can't have the same sign. They have to be at least one of them has to be negative for y. Because since we're solving for y, right? So basically, one of them has to be at least a negative sign. Okay. So when we are solving this, it'll be the top equation will be the same. Okay. So 2x plus 6y equals to 18. And then this one will be negative 2x minus 6y equals to negative 18. Now, I'm going to just get this thing off because it's going to... Now, if you add them together, negative 2x minus plus by negative 2x equals to 0. Plus 6y equals to negative 6y equals to 0. And 18 plus by negative 18 equals 0. So you can kind of see that they're all equal to 0. So negative 2x, you can just basically cross them all out. And when you do get that, it's 0 equals 0. Now previously we talked about the review of about what kind of systems equal to what kind of solution. So now the solutions were no solution, one solution, and infinitely many solutions. So this solution is actually true. Sorry, this answer is true, but this one will be as infinitely many solutions. And this is like the most common word that they this is the most common answer they use when it's 0 equal to 0, due to how it makes more sense. So like if you put 0 equals 0 on the answer in the system, it will not really comprehend of what it means. So you're gonna have to at least put infinitely many solutions or something by true. Not sure about that, but it depends on what kind of system you have, and or if you're writing or if you have like a if you were like writing, or if it's like in pencil and paper, that's fine too. You can just put infinitely many solutions or 0 equals 0. It doesn't really matter. But unless your teacher tells you to put what kind of solution it is. But basically, this is how you solve infinitely many solutions. Okay, so this is the third problem, and this one says solve the system by elimination, and it's the same one, but now it's fractions instead of whole numbers. So you see how it's 9 over 5x plus 6 over 5y equals to 4, and 9x plus 6y equals to 9. You see it's kind of confusing due to how it's like fractions now, and you know, it's just like, how am I gonna solve this if I don't know what to do, you know? But I'm gonna show you guys how to solve this, okay? By fractions too. So it's a little more complex than I thought, but I'm just gonna see how it goes. So what we're gonna do now, or the first step we're gonna do is we're gonna try identifying what we should do to multiply one of the equations. So this one seems fine. We don't have to multiply this one. So this one is just gonna stay the same. But this one you can kind of see like what we can do to make this fraction go away and make this the same. And that's the most difficult part to see what should we do, because sometimes fractions don't seem the way sometimes fractions are way more confusing on how to solve it. But since this one has the same denominator, it'd be more easier to solve. So this one, let's solve this by -5. Okay, so it's basically gonna like what? It's gonna basically exit out. So if we eliminate it by -5, it's gonna take out the fraction. So it's gonna take on 5 and 5, the denominator 5 out. Okay. So when we do solve them together, it'd be so -5 divided by 9 over 5 would be -9x, and then it's gonna be minus 6y equals to -20. Well, why is it -6y? Well, because of -5 times by -5 plus by 6 over -5 times by 6 over 5 would be crossing out -5 together and leaving it to -6. Okay, same thing with the 9. That's why it leaves with -9. Okay, now we're gonna put the same equation right here. No, don't do anything with this equation because it's already simplified. Okay, plus 6y equals to 3. Now you add them together. So this one, so -9x plus 9x will equal to 0. -6 plus 6y equals to basically 0 also. And -20 plus 3 actually has a meaning. It actually equals to -17. So you can kind of see what kind of solution this would be now, because this one would be basically equal to -0 equals to -17. So this one, as I previously talked about in the review, I talked about how there are different kinds of solutions. And the last one we did was talking about infinitely many solutions. That was a true answer. But this one seems like this is not a true answer, because 0 does not equal to -17, right? Because 0, if you want to equal something to 0, it would be 0 equals 0, which would be true, right? But this one is actually not true at all. This is not true at all, because 0 does not equal to -17 at all. If it was x, then maybe that would make sense, right? Because you solve for x, but this one just says 0 equals -17. So this one is no solution. Oops. So basically, when you are solving throughout this if it's 0 equals negative 17 is not true, that means that's a no solution. So a no solution would be, it would be parallel. It would be like a parallel graph. So basically this is how it is. And yeah, so on system you'll be or in pencil paper or system, whatever math system you use, you're always gonna put no solution, so they know what kind of solution it is and why, like how it is, like basically they're gonna see how it makes a difference and how it is no solution. So this is how you solve no solutions.